And so what is everyone's experience with Rhino? Maybe we'll go one by one and just let me know like if you've used it or not. So Ashley, you're in my top left. I'll go this way.
I used it a lot in undergrad, and it's been some time since then. So just kind of seeing what changes have been made, if any, and kind of go from there. I'm in AFS 3 next semester, so I figured it would be useful.
Okay. And Ian?
Just a little bit in Viscom, which I'd struggled with it there, and then in your simulation and prototyping, but that was mostly Grasshopper.
Yeah. Yeah. It's funny that you can be as advanced as you are in Grasshopper, but maybe not that advanced in Rhino. but that's okay. Susan?
I've used it quite a bit, but I've never had any formal training, so I thought this would fill in the gaps for me.
Okay. And Christy?
I'm the same as Ian. We were in the same classes, so I think we probably had the same exposure.
Okay. Lena? I can't hear you so well.
Can you hear me now?
A little bit better, yeah.
Yeah. I said that I haven't used it before. I don't know if it's the same as Revit. Other, I don't know. So I want to have an idea about it.
Okay. And Renee?
I don't know it at all.
Okay. That's what tonight, that's how I'm gonna run this, is that you've almost never opened Rhino before. So it might be a little slow for some of you to start, but maybe like I think Susan said, it's like maybe it might be the most basic thing, but maybe you didn't know that's how that worked. And I'll try and point out a few of those tips, and we'll talk about some of those things. And the plan is that over the course of over tonight and tomorrow, we'll develop a kind of little project. We'll do a couple drawings of it. We'll do a rendering of it, and you'll have a kind of really quick just iteration of going through a kind of simple project. How about you, Eugenia?
I never used it before.
Okay.
That's okay.
That's okay. Not a problem. Bettina?
Same as Christy and Ian and Bizcom.
Okay. I want to see you too, Bettina. You're always so shy on Zoom. Daniel, are you with us? Maybe not. Okay, so others may join.
Sorry about that. I was muted on my computer. Yeah, I used it a little bit in my undergrad, but I haven't really touched it since like 2012. So it's been quite a few years.
Okay. And for you and for Ashley, I'll say I had a kind of crisis maybe last night or the day before. I was telling Dale about this too. The kind of workshop that I'll run through, I did for a few years. I taught the incoming graduate students at Michigan in kind of a one-day Rhino Bootcamp, but I realized it was 2004, 2005, and 2006. And I was like, I did the math. I was like, oh my God, that was 17 years ago. The other really weird thing about it is that I pretty much didn't change the outline for this. And so like on one hand, like that was so long ago. On another, like I've been thinking more and more about it, and it's really incredible that so I've been using Rhino for I guess like 20 years now. And the interface hasn't changed really that much. And so on one hand, it's problematic to me because we talk about software changing so quickly and that you have to constantly keep learning these things and keep doing these things. But on the other hand, like I've started to think about that more. Like it's actually really interesting to me that Rhino looks the same. So I think, Daniel, if you were like, you haven't used it since 2012, my guess is it's going to look exactly the same. there may be a few new buttons, there may be a few new things there, and Rhino 7 brings some additional capabilities, but for the most part, it's going to work the same way. And so for me, that's something that's kind of nice, and that it's pretty stable that way. And so hopefully, Ashley, for you, if you've done it before, you might just be able to kind of pick up where you left off. And then the other thing, I'm kind of working off of the outline that I emailed all of you. And so if you kind of want to follow along or take notes or anything with that, and I'll just start a little bit with like some of these aspects about why Rhino, and the fact that I'm using the same outline from 2006 for me is a kind of positive selling point about these things, and that you'll be able to come back to it. You'll be able to work in this way. The other reason why I really, when I started using Rhino, it had to deal with fabrication, and Rhino has set the standard, in my opinion, for software that will play well with other pieces of software. And so when we get into it in a second, I'll go to open and save. There are a ton of file types that Rhino will open. And often you may be working with a specialized program, and Susan knows from this summer with critical practice, working with the structural engineer, there's like file types that we can open and file types that we'll be able to save. And so some of those things are pretty incredible. And so much of what we're starting, well, so much of what we do in design is we'll flip-flop between different types of software. And Rhino becomes both something that allows you to translate one file type into another, but it also allows you to kind of work, right? We'll be able to save a rendering as an image. We'll be able to save out an Illustrator file. You'll be able to save out a file to 3D print with. You'll be able to save a file to operate a CNC router. You could save file types to work with the robot. And that's a pretty amazing thing. It's really versatile that way. And that term is called interoperability in kind of software speak. And it's really important for those kind of workflows to be able to move between them. And the more seamless, the better. And Rhino is really good at it. I'll also share or show you guys, there's lots of different ways to work in Rhino. You can work by using the icons. You can work with hotkeys. You can work by typing in the command. And you can really begin to customize it for what you want it to do. So much so, I'll show you a couple tips tonight. You can make your own hotkeys. And I've only just recently gotten back into using Rhino to model something. I have a couple of houses that I've been working on this summer, and I'm drawing the plans and I'm modeling them in Rhino. And every time I do a command, I'm like, oh, I need to set that shortcut, right? So L, for you guys, if you're just opening the software, L is like lasso, which is stupid in my opinion. It's like I'll instantly change L to line, right? Because when I hit L, I want to draw a line. And so whenever I see myself like, oh, if this is more intuitive for me, you could set every single key to do a different command. You can also set macros, so you can make your own button. And I have like a couple of commands that'll it'll do one thing and then another thing. And so you can really customize it that way. So there's a couple different types of modeling as well. And so Rhino is a surface modeler, and this is good in some circles, bad in other circles. The distinction that I would make is that, and we'll see in a second, there's an option for solids. It's kind of faking a little bit working with solids. We will work with solids. There are other programs that are really solid modeling programs like CATIA, like SolidWorks and other things. When we make a solid in Rhino, and I'll show you this and I'll explain the kind of hierarchies between these, that a solid is basically just a set of surfaces that makes a watertight closed volume. And we'll be able to explode it, and then you end up with surfaces again. And so that's just to put it in the context of, and I'll also show you the shortcomings of it as it relates to this when we get to some of the solids. It also is a NURBS modeler. And NURBS stands, I can get like super nerdy with you guys when it comes to these things, but NURBS stands for non-uniform rational B-spline. And what it basically means is that there are another distinction of two types of modeling programs. One is software that uses polygons or a mesh. And so something like 3D Studio Max and I want to say Maya will use polygons. And so a polygon, basically a bunch of little triangles, and we can do something later tonight where you'll see the difference. It's really good for rendering because the triangles don't take a lot of memory, and the algorithms to render kind of smooth those things out. But the NURBS modeler and the NURBS surface modeler, Rhino comes from the jewelry industry originally, probably in like the late 90s, early 2000s. And a NURBS surface modeler means that the calculus of the surface is that at any point along the surface, you can calculate exactly where something is. And so this is really good when it comes to machining, when it comes to fabrication, when it comes to other things. And so, and I'll even show you, right, we can cut a surface, we can work on a surface, we can subdivide those surfaces, we can do all sorts of things with them. So it's a very robust surface modeling tool. And then the last thing, which is just as important, is that as a student, as an LTU student, all of you can get the software from the school, but you, as a student, you can also get an educational version, I think for $199. And I think when you graduate, they'll translate that into a commercial license. And so it's really inexpensive compared to the capabilities that come with it. And it's for that reason that I would say, and many years I taught CATIA, but that's a $10,000 piece of software. And most architecture firms will not ever purchase a $10,000 piece of software. And so it's unlikely, learning CATIA, it's unlikely that you might come in contact with it, except in very rare circumstances. Rhino is a really good tool. Like I had a small office for a number of years. We used Rhino because we could model something, we could draw something, we could do everything we needed with the software. I wouldn't do construction drawings with it, although I'm gearing up to possibly try. I have been doing presentation plans and sections and drawings from Rhino. So you can do some drafting with it. So any questions about any of that stuff? Should I share my screen? We can start looking at what it looks like. Move you guys over here. You can see my screen, right? And at any point, there's a small number of you. So at any point, if there's any questions, just stop me and we can talk about those things. So what I'll do first is I'll just talk about kind of the layout that we see on the screen, how we navigate it, how we understand some of those things and where they are. And so for some of you, if you've played with Rhino before, this might seem a little simple and obvious, but for those of you that are opening it for the first time, we'll just kind of work through some of these things. So what we see on the screen are the four big windows are different views. And so we see the top view, the front view, the right view, and maybe what I'll do is I'll make a really simple object. You guys will laugh at me too, and maybe specifically Ian will laugh at me because I can do a lot more in Grasshopper than I can do in Rhino these days. But here's, and maybe I'll make one more weird object just so we can see the differences between the different views. And so even here's the thing is that you can see my cursor. I started drawing something in the top view, and then I can move my cursor to the front view or to the perspective view and then complete it. And so what we see on the screen is the top view, the front view, the right view, and the perspective view. And that's the kind of default I don't usually work in all 4 windows, but if you're working with 3-dimensional geometry, it's sometimes useful and sometimes very good to see the top and the 2 sides. So the things that I drew, one cone looks the same in 2 of the side views and is a circle from the top view. This rectangle you can see is long in one direction and short in another direction. And so having these orthographic views is helpful. I'll say, well, maybe before I say that, the other convention is that, I can move these off to the side, is that you'll see in each window, if you zoom out, and if you've never used it before, you can stop me and I'll do these things, but simple navigation is that any window that you're in, if you use the scroll bar to move in or out, you can zoom in or out. And if you're in an orthogonal view and you hold down the right mouse button, it'll pan. And then the left mouse button, you can select the objects. And so the convention is that as it's selected, it turns yellow, which is also my caution, that when you start using layers and layer colors, you don't use yellow as a layer color because you'll think those things are selected already. So the other thing in terms of what we see is a grid and a red line and a green line. And so that represents both the origin. And so each of these work in a coordinate system. And the simple rule of thumb is that if you use your left hand, that the origin, which would be like this for you guys, is that it's positive X and positive Y from the origin. And so if we put a point and we just type 0 and enter, this is a point now that's at 0, 0, 0 in terms of the coordinate system. And so we can see that that grid is a flat surface, and we can see the positive X and positive Y just as our frame of reference with all of these things. I tend to work, and so while sometimes it's useful to see top, front, and right, I tend to always just maximize the perspective view, and I'm constantly kind of navigating and moving around in the perspective view. And I'll do this, and there may be moments where we can kind of switch back and work on things a certain way. Any questions? Too fast, too slow? Make sense? I know probably way too slow for some of you. So then in terms of the interface, the other thing that we see, just to kind of talk about these kind of key parts, off to the right are the layers. And so there's tabs across the top, which is properties, layers, rendering settings, material settings, and help settings. And so for the most part, you'll use layers. We can name any of these things. And then the kind of convention here is that the check mark means that it's the current layer that you're working on. So if I draw something here, it's red and it's on the red layer. If I move that check mark down, if I draw something else, it's going to be purple. I can turn these layers on and off, and I can lock them. I can also set display colors, line weights, and other things within the layers if you work that way. Across the top, there's a set of menus. So file, really standard. And so I mentioned this earlier in terms of opening. Here I'll do save instead. Save as. So depending on the geometry that we have, if I pull down this, you can see I can save it down Rhino 5432. I can save 3D Studio Max files, DWGs or DXFs for AutoCAD, Google Earth, KMZ, IGES, OBJs for, that'll be a polygon model for like VR things, SketchUp files, and other STL files, Z Corp for 3D printing. So we can save, depending on what type of geometry we have, we can also save Illustrator file here. And so it's really good at saving different types of files. And so you can just kind of like poke through these. Any tool that we need, we can access from the menus on the top. And so file is like save, export, open, and new. Edit. Yeah.
When you open, does it go both? Can you import as many files?
Yeah, I'll do it. It's like, do you want to save it? No, I'm not going to save it. So in terms of open, the same thing over here. We can see, so Rhino files, you can open an Illustrator file. Sometimes you might lose like layers or they're not kind of perfect conversions, but you can open a DWG, a DXF, an EPS, an IGES file, OBJ file. And so it seems pretty comparable in terms of those STL file, maybe a couple of others, points file, maybe for other kind of like a text file that had all the points. So there are a lot of file types that it also opens to. I tend, and I guess I didn't lose that. There's also some icons. And so you can see the standard view, depending on if you want to use these: new, open, save, print, copy, cut, paste. And then there's tabs that come across the top. I might use some of those tonight and we can talk about them. But when I've started learning these things, the top menu is like the most comprehensive thing, because what starts to happen, did that even just change standard? So you can see as I change those tabs, the tools on the left are changing that run up and down the side. And if you're not familiar with them, if you mouse over them, it'll tell you what they are. I tend not to use the icons when I'm modeling, because I can be a lot faster with other things, right? So if I type L and the space bar, now I can draw a polyline, right? And so it just, for me, it tends to be a little bit slower in terms of going and finding these in any icon on the left. If you hold it, if there's a triangle and you hold it down, there's all of these other tools underneath there. And so if you get used to working with the icons, that's okay. You can do that, that's your preference. But sometimes I still tend to use the menu at the top because I know that there's curves and curve from objects, and then I want to do something with one of these, right? If I don't have that shortcut. So view, there's some options here, but there tend to be a lot of shortcuts. What I would point us to is maybe just a general working method up here is a kind of hierarchy within Rhino that, and I'll show you this in a second. We can move from a curve to a surface to a solid and back. And so I use these three on the top to be able to do things with curves, things with surfaces, and things with solids. And so it's kind of fluid in being able to move back and forth between those things. And so any object, for instance, like if I wanted to extract one of the edges of this rectangle, I could go curve from objects, duplicate edge, and I could get that line, right? And then I can move it over, right? And then I have that line there. And so that becomes a new object. And so we can extract geometry from other geometry. We can cut, we can make intersections, we can do other things, but we can then take this line, for instance, and we could extrude it. So if I take that and extrude curve straight, right? Now I've just made that, and I can change my display. If I right click on perspective, you can see here's different approach: wireframe, a shaded view, a rendered view. I also tend to work in ghosted view. I like being able to see the kind of different objects and different things that are there in the ghosted view. And so we'll play a little bit tonight with going from a curve to a surface to a solid. There's mesh tools within here, and those are, again, the kind of polygons. Dimensions are if you want to do drawings and you want to put dimensions on things. Transform. And so what I would do as I start to learn these things is just kind of go through and say, okay, let me make each of these types of curves and see what it does. Let me understand what each of these surfaces do. And I'll work through a few of those over the next 2 nights with you guys. Transform allows us to kind of exactly what it says, transform. That's the other story that I tell about Rhino, is that it's pretty intuitive. And so like when you want to do something, even if you don't know exactly, right? I want to contour something. Luckily enough, it's called contour, right? Not all software is like that. And so sometimes you can just type it. If you want to do something, let's see if it works for me. If you're in the middle of so what I did a second ago, right, is that if you hit escape, and so here's the other thing to say, right, is that this is the kind of status bar. I can drag it and expand it, but we can see if I scroll back through all of the commands that I've done here. And so if I type contour again, and it starts, now it says each of these command lines like, okay, select objects for a contour, and then here's some options that we have. If I'm not sure what to do, if you type, or if you click the F1 key, function 1 key, it'll do what this just did a second ago. It will open in the browser the kind of instruction manual for Rhino. And this is the contour. This is a description of all the things that you can do with the contour tool. So that's a really great, really connected thing as you're working through these to have that kind of access to that. And again, you just type, or you just hit the function 1 key and you get that for any of these commands, right? Let's see, Boolean union, F1, short video, here's how it works. Here are the different options underneath it and what that might do. This is almost like way too much information, but at least you have access to that. I think there's also off to the side. Yeah, so over where the layers are, if you go to the far right, there's a help window. And so any tool that you're using, as you click on the tool, it will open a dialog box that tells you what that thing is and what it does and what the options are. And so that's really helpful. So we had transform, kind of obvious move, copy, rotate, all of those things. There's some tools. I think the only thing I ever really use under tools is the options. And so if we want to change some of those hotkeys, we can do that here. Analyze, there's a couple of useful tools under analyze, and then rendering. You guys may have other things. I guess there's panels. Paneling tools might be an add-on for me. Do you see paneling tools? No. That may have been something that I added. And then the last part, right? So we know, I said this before, that as we change these tabs, the icons on the left are also changing. Down on the bottom of the screen, there's a couple of things, and these are the snaps. And the snaps are really, really helpful. They can be helpful. They can also be unhelpful sometimes, I guess. But if I want to draw, let's say here, you know, I'm going to change. I think I set my screen to look a certain way. Now I think you guys can't see so well. Appearance, colors, restore defaults. Okay, maybe this is the default now. So snaps, if I were to draw something, let's see. And you can see as my mouse approaches something, probably the default, like probably you guys have our end, And so down here at the bottom, you can see end, near, point, mid, center, intersection, perpendicular. As you mouse over something, it will snap to them in a certain way. So end is really useful, or that's an intersection, or to that end and that intersection. Let me change my layer so it's more, I'll go to white, might be more visible. So if I draw a line and I want to just connect between these, that the snap allows you to, exactly what it says, snap to different things. And so for me, if I watch you modeling something and you have near on, near seems like a good idea, but it's a really bad idea. It just means that it'll basically snap to anything that's near it. And so I would never, ever have near on unless I'm not trying to be so specific or too accurate about it. So, and what you can do is turn some of these on and turn some of these off as you're doing it. So like mid is on, right? Well, we should be able to find, there's the midpoint of that. And that's perpendicular. Right? And so if you're trying to, sometimes center is not helpful, but sometimes it is. And so you might be able to find the center of an object. Right? That just snapped to the center of the object, which is there, but sometimes it might get confused. And so maybe I'll turn center off until I need it. All this make sense? So we kind of talk, there's kind of general interface, kind of basic things that are going on. My rule of or maybe the way that I tend to work is in inches. And so when I make a new file, I don't want to save the changes. I usually do large object inches. So if you're used to working in metric, maybe don't do this, but at least like for the residential projects that I'm working on, I like to be able to put in, right, I can draw something. Maybe I'll draw a simple rectangle. I'll start at 0 and I'm going to make this 48 inches wide and 96 inches high. Right? A basic sheet of plywood is that proportion. What's nice within Rhino is that I could also draw something, even though we made that choice to work in inches. I can start here and I can make it 4, and then if I type feet by 8 feet, I can use other units as long as I specify those. I'm going to embarrass myself with metric, which I'm not even going to make a sheet of plywood with metric, but I could say 60 centimeters by 90 centimeters, right? So even though I'm working in inches, I can specify something in feet. If I were working in feet, I could specify something in inches, but at least at a residential scale, I'm usually more familiar with things in inches, and I tend to work that way. So starting a new file, right? New file, work within inches. Large, the difference between choosing large and I forget what the other option is here when we do new, I think is the construction plane. So you'll see that there's large objects inches and small object inches. And so I think if I draw something now that's 48 inches by 96 inches, it probably doesn't matter too much. I think this tends to set the tolerance and the constraints for some of these things. So at an architectural scale, at least large objects inches has been the best for me, I'll say. So we should try and draw some stuff, and that'll allow us to talk about a couple of things. And then maybe we can get into, maybe we'll come back to layers and organization and other types of conventions. So let's draw something and maybe just make a circle and draw a circle in the top view. And so what we see is the circle then in the 3D view on that plane. Maybe it's just an opportunity now to talk about construction planes and the way that works and the way that we model things and how we go about building up something. So a construction plane, and Rhino is kind of cute in that they have C-planes, which stands for construction plane. And they used to have a little icon, like little seaplanes, like they have little cars, but like a seaplane, like a plane that can land on water. Now it seems like they've gotten rid of those. But the construction plane, and I have a new understanding of this recently because I've been also working with Gravity Sketch, and Gravity Sketch allows you to draw 3-dimensionally, which is the only way that I know how to draw 3-dimensionally. And what do I mean by that? Because we're working within 3-dimensional software, but the mouse is on your desk and your desk is a flat surface. And so the way that Rhino works, and even if we were to sketch something, so if you come to curves and there is a sketch tool, and if I hold down my mouse, I can sketch a really sloppy line and it makes a flat, right? That 3-dimensional thing that I drew is flat on the construction plane. And that's true if I do that in the top view, like that, right? So if I look at it here, it's flat. If I draw it in the front view, it's flat according to the front view, right? And so when I say sketch something 3-dimensionally, I mean that all of a sudden it's X, Y, and Z and kind of all over the place. We can fake it a little bit within Rhino, but I think it's useful, and certainly in terms of architecture, it's useful thinking about always working on a flat construction plane. And we can move the construction plane around in order to draw different things. And we can do that now. So maybe if all of you want to draw, let's make a really simple object. And so come down to the rectangle tool. And there's corner to corner is the default. And so if you click in 2 places, you'll make a rectangle. I tend to always opt for the rectangle 3 points, because that way I can set a dimension and then I can set the other dimension, because it's basically like, what's the width and then what's the height. So did everybody draw a rectangle in plan? Super easy, right? Yeah. Give me a nod. Yeah. So let's extrude it. And we can do this just as, let's do it as a solid. So if you come up to the top and up to solid, we can extrude planar curve and straight. Click on the box and then it says select curves to extrude, press enter, or you can right click. And now if you come to the side view, you can see this. My option here is set to extrude on both sides, which I don't want. I can set that to be no, and now I can just extrude it straight up. So now I have a nice little cube. If I use my right mouse button, I can navigate and spin around that. What's useful to see is if you click down on the bottom of this, there are 2 objects on top of one another. And as you select something, Rhino gives you like, it's like, I'm confused. I don't know which one you want me to select, right? But I want you to see that the curve that you drew first is still there. and the extrusion is there. And so whenever you're trying to select multiple things, you can also, the kind of other convention is that if you click with your left mouse button and drag left, it makes a dashed line, which is if anything crosses that, it'll select it. If you go from left to right, it's not a dashed line, and that has to be a window. And so you can see that's not selecting it. If I window, because it's selecting fully the box, it'll select the box. If I go from right to left and just mouse over it, or just grab a little bit of it because it crosses it, it'll select that. Are you guys familiar with those conventions in terms of window and crossing? I think it's similar in Illustrator. It's similar in other software. So now we've got a box. Let's draw something that intersects the box. And so let's draw a circle in either the right or front view. And I don't know if I want it to, maybe I want it to hang out a little bit outside of that first thing. So in the right view or the front view, draw your shape and have it kind of spill out over that. If we look in the 3D view at the top, what looked like that circle being drawn right on that surface is actually much further out in front, but that's okay. And let's do the same thing. We'll go to solid, extrude planar curve, and straight. We'll select it. And then we can either extrude it all the way back, or we could extrude it a little bit and then move it. But let's extrude it so that it passes all the way through. And you can see that in the other views. And at least my right view looks exactly the same as it did a second ago. Make sense? You got it? Let's do, this is a little bit like a magic trick, I think. Let's do one thing before I was going to do what I was going to do a second ago. Let's select the extrusion and let's just make a copy of it. And you can type copy. It's probably the easiest way. And then if you click and maybe just drag it. And if I don't know if your conventions are the same. As we're moving it, if I hold down Shift, that will lock it to be an orthogonal transformation. If I let go of Shift, it could be a non-orthogonal. I just want to drag this up, straight up, and so that I have a copy of the box there. Does everybody have a copy of the box? And so here's a moment where I just want to show you that that box, which is a kind of solid, or I'll show you the way that it behaves as a solid when we cut one of these out of the other thing. But if we explode it, and so explode is this icon down here, but you can also type explode. I think I can even just type X. So I have a shortcut set for X to explode an object. Well, let's explode the object that we copied. And let me explain just a couple of other things while we're here. So when you exploded it, a couple of things looks like it happened. All of a sudden, there's these extra lines over here on our other box. Those are called isocurves. And as you click on this, you should be able to select those individual faces. And maybe it's useful if you right click on perspective, set it to ghosted. And so you get, what's nice with ghosted is you can start to see the front and back face of all of these things. But if we select one of these surfaces and then delete it, now we're seeing inside of it. And so by exploding that solid box, what we did is we took something that Rhino understood as a solid, and really what a solid is in Rhino is a poly surface, meaning that it's made up of multiple surfaces. We exploded it, and now those are all individual surfaces. we can join them together. So if you select all of them and then Control J, that turns that into one object now. So if we select it, we can see the whole thing turn yellow, but it's not a closed volume. And so imagine this as like a box without the top. It's just an infinitely thin set of surfaces that hold space within them. Whereas our object over here, we haven't exploded it. Rhino understands it as a solid. And so I'll show you the difference with that. If you go up to solid at the top, and then we'll do difference. And it'll say, you can always look at the status bar here, select surface or polysurface to subtract from. I want to select from the box and then press enter to continue. I think you can hit the space bar to continue, or you can right click to continue. And now it says select surface or polysurfaces to subtract with. And so I'm going to select the cylinder and then hit enter. And now that just cut one out of the other. Did that work for you? Couple of nodding heads. Yeah. You're muted, Susan. Or you're not talking to me. So this is the difference now, right? We can explode this surface, and we can always come back, but I'll type explode. Now we can delete that top face, and now we can work on any of these as separate surfaces. And even this we can see, because the cylinder was made probably out of a couple of parts, this could be joined back together. We could copy this and even just have that part off to the side. If we want, right, these are all individual faces now. If we wanted to close this back in manually, right, obviously we can undo, we could do a couple of things, but let's make a surface, let's make a plane that's corner to corner. So if you come up to surface on the top, plane, and corner to corner, select one corner of the top surface, the other corner of the top surface. And then if the thing I don't want to do is select that curve on the bottom. So I'm going to delete that, because what I want to do is join all of these back together. So if you have your first box on the bottom, you can delete it. But now make a window, select all of these, and then Control J is join. This now just turned back into a solid as far as Rhino's concerned. So if we want to try that, let's cut another cylinder out of it, but from the top. And so the way that we would do that is to draw another circle. And I want to be careful, because what can happen, let's see if this happens. Let me show you what I'm afraid could happen is that, this is true. For a circle, it doesn't matter apparently. So let's draw another circle over our box, and let's position it so that when we cut through, no matter if it's on the top or the bottom, I want it to cut through this other cylinder as well, but just a portion of it. So I'll select that and let me extrude as a solid, extrude planar curve, straight. And in this case, Rhino can be a little fussy when things are right on top of one another. And if we're going to cut something out of something else, we want it to be bigger. And so I'm just going to extrude it beyond that surface. And then even in the front view, I want to move it down a little bit so that it's hanging out on either end. And so that when I cut this one out of that one, and remember, we started with a rectangle, we turned that into a solid box. We exploded that box a second ago. We just drew another surface in and we joined them back together. And now we're going to treat this again as a solid to do the difference of keeping this object. Select the polysurfaces to subtract with. I'll select the other cylinder, and then I'll cut that out. Right, so now we have those two subtractions that also intersect and cut out another piece from that. Did that work for everybody? And so we start to get things kind of layered up on top of one another in these different views. But you should have, and I can go all the way back to making that full screen. We can see that kind of almost a double negative here, right? The subtraction from the subtraction as we look at them in two different ways. And so we really do need a three-dimensional view to understand what's happening here. One, and I guess you guys are with me, right? Am I going too fast? Do you want me to go faster or slower? I can go way faster if you want.
I'm a little bit behind, but
Okay.
I can.
What can I help with?
I got lost on the first cylinder
Okay.
and how to.
Well, let me do this. We'll remake it, and it'll give me a chance to reinforce something else that we're talking about too. And I'll leave that off to the side. And what I want to show you guys too is to start to talk about the role of the construction plane and the way that that works. And so let's make another rectangle off to the side. And you can see when I've now moved to just work in the perspective view, in the one big view, the construction plane becomes that much more important. And so you can see, even though I'm not drawing explicitly on the construction plane, whenever I draw anything in the 3D view, the construction plane where it's currently set is there. And if I'm not snapping to anything, and this is the distinction that I want to start to make now, if I'm not snapping to anything, it defaults to the construction plane. And the reason why I say that is that watch what happens when I'm just going to draw a control point curve, and I'll do it a couple times, right? If I just draw, if I snap to this, that's going to be fine. Right, this curve now is still flat. But watch what happens. I'll delete it now. Watch what happens. The snap will override the desire for the geometry to be on the construction plane. So if I draw another control point curve, right, I'm not snapping to anything. I'm not snapping to anything. I'm not snapping to anything. But when I get over to here, I choose end. And I choose end, and then I come back and I'm not snapping to anything. When I rotate this view, those 2 points will have pulled, oh, even more weird. I don't think it should have done that, but I guess there's a new algorithm. So look at this curve now, that when I wasn't snapping to anything, it was on the construction plane. I snapped to this three-dimensional object that was up here in space. And then I think the new algorithm says, because I'm not snapping to anything, it keeps it at the elevation of the last point. Right? So all of a sudden, this could be really good for what we want, but it could also be really bad, because what I thought I was doing was drawing something flat. Right? And so you just want to, you'll really quickly get a handle on when the snaps will override, when you want to be working on a construction plane, and how we can override both of those things. Right? And one way to override that is projection. And so down here at the bottom is a projection. It's down with the snaps, but if you have project clicked here, watch the difference of what happens is that, right, I'm drawing something, I'm not snapping to anything, but when I come over here, what it's doing is that it is snapping to that corner point of that object, but then it's also projecting that thing straight down to the construction plane. And so project will override things that are in kind of a different plane to kind of force it back down to the plane. And so this could be a really useful thing, not for what I'm drawing now, but let's say I want to understand maybe this object, what it might be kind of in plan, right? So if I could snap to something along that edge, which is maybe the quad on the other side, right? That projects down and then it closes, right? So I've kind of drawn the projection of this object down on the construction plane. And so that's project is a really useful tool that way. There's also another way to do it, and this starts to get into more geometry and projection. And the reason why we need to understand these things is that we're working in a kind of fake three-dimensional space. And this is a little bit of, it can start to mess with your mind a little bit. Your mouse is working on a flat surface. You're drawing in three-dimensional space. And so often, like, let me do this for a second, right? I'm drawing over here, right? And I think I just drew a kind of circle, but I'm in three-dimensional space. So when I actually turn the view, oh, that's a weird looking shape, right? I thought I was drawing something that was very different. And so you have to always kind of understand how you're working or where you're working, how you're using the construction planes. And then there are other ways too that we can override some of that. So I'm going to turn project off and do what I did a second ago, right? Which I said was a kind of mistake. Maybe snap to a few of these things and then draw that, right? When we look from the side view as we rotate, this has height to it now, so it's not totally flat. But Rhino has a lot of tools. So under curve, we can curve from objects. We can project this. We can duplicate it. We can find an intersection. We can contour it, section it. What I really want is a tool that it's not right here. And offset. And luckily, what I want is, let's see, hold on.
Do you want to set the plane?
No, what I wanted to show you is project to C plane. And so what's nice is that you can, as you type project, you'll get all of the different tools with project and other things. And so what I can do is project to C plane, which will take that object, select objects to project, press enter. I can keep the objects or delete the objects. But now you can see that new object that was created is a straight projection, so that when I look from the top, it's the same, but when I look from the side, it's totally flat, right? And so there are ways that we can then project geometry onto other types of geometry. And so it's also just to say, it's going to be really common that you'll be doing something and then all of a sudden you'll rotate the view and realize like, oh, that's not what I thought I was drawing. That's not what I intended. And that's just because as you start to understand these things, the geometry wants to be on the construction plane, but a snap will override that. But then there are other ways to work with it too. And so and so for Renee, let's do something, and I'll do the same thing, but with different tools and in a different way. So let's take if you guys follow along, let's draw another rectangle off to the side. The proportions don't really matter. Rather than making a solid this time, let's make a surface. So we can extrude the curve straight. Select the curve to extrude. We'll extrude this up, right? And now what we did is we just extruded that curve. It doesn't have a top or a bottom, but that's okay. Let's draw We'll go back to the 3D view for a second. Let's find it. So if we click on it in one view, oh, I actually thought it was this one. We can see where it is over here. And let's draw. We'll do a similar thing. We'll make another circle. We can drag this a little bit. And then we'll extrude it. So we'll do that in 3D. And let's do surface again and extrude curve straight. I'll make it a little bit longer. And in this case, I'm going to go back to the top view. Find it. And then we can also use, you can see there's a little bit, there's this green and red line and then a blue line. This is called Gizmo. It has a name, I forget what it is. And it's relatively new in Rhino, but if you
Gumball?
click Gumball, yes, that's right.
Yeah.
So if you use the blue, it'll rotate it around. And I'm just going to do Control Z to go back. If we use the red line, it'll lock it to slide it orthogonally that way. Control Z to undo. Green will go in this direction. And so I just want to slide it a little bit so that it intersects through our object. I'm going to delete the circle that I drew first. So we can do a couple of things here. And maybe we'll do one and then the other, right? And so what I'm getting you to start to understand is like, okay, we extruded one object, we drew something, we extruded that through it. We can get different types of geometry because Rhino is really good at moving between curves. And I say curve, but a curve can also be a line in Rhino speak. Line, polyline, rectangle, all of these are curves because they're just two-dimensional geometry, although I've also shown you that it can move into 3D, but curve, surface, and solid. So this time we made two surfaces, but from a curve, let's go to curve from objects and let's get intersection. I think intersection, we'll see. So select objects to intersect. We'll select our cylinder and hold down Shift. And we'll select our extruded rectangle. And now you can just barely make it out, but what we got is a curve at just where those surfaces intersect. So if I move this off to the side, what it gave us is that intersection. So as I spin around, and it didn't do anything to our previous geometry, it just created a new set of curves because we did curve from objects, and then we got the intersection between those two. And it created a new set of curves for us. If we want to work on this as a surface, we can also do that. So let's we can trim two surfaces. So if we go to surface and surface edit tools, these are the moments where I don't actually even know where this tool is, but it's a really simple tool. It's just called trim. And so it's Control T, probably for you as well. And so select cutting object. Let's select our cylinder, press enter, select object to trim. We'll select our box. And it trimmed one out of the other. Or if we meant to do it the other way, we can Control Z to undo. Control T, select cutting objects, select object to trim. And now our cylinder has been trimmed inside of our box. And then we can do the opposite. Select cutting objects. Let's select our cylinder. Hold down Shift. And now we can trim the rest out of there. So in this case, we can build up a solid This is just a set of surfaces. We can select them individually. But if we come back and we draw, say, a surface, plane or surface corner to corner on the top, and on the bottom, we join this together. As far as Rhino is concerned, now this just became a solid again. So what I'm trying to show is just this kind of both kind of hierarchy from curve to surface to solid, but also the kind of malleability of being able to get curves from the solid, or curves from a surface, or a surface from a solid. We can duplicate any of these, we can copy any of these, we can work on it in different ways. Does it make sense? Is it helpful for those of you that have been used Rhino before? Does this add to your understanding? Are we good? Did that second time around help you, Renee?
No, I just have one screen, so I'll go back and watch the recording. I
Okay.
think so.
Okay.
I'll do my best.
That's okay. And I'll just try to keep reinforcing some of these things too.
Yeah, it was pretty fast, even for me. I didn't quite keep up, but I mean, it's fascinating. But you know, like she said, the recording's there, right? So that's the beauty of it.
Right. And some of this is, I just want to kind of along the way, maybe show some examples of things, or show the way that we can do some of these things. The other thing is that there are some useful other tools. And so one of which, right, and again, I'm working in the perspective view 3-dimensionally all the time and kind of spinning around. We can make some very simple drawings. And so under dimension, there's this really great, well, I'll say really great tool. You can run into trouble with some things, but it's called Make 2D Drawing, or just Make 2D. And so select objects to draw, and I'll select that poly surface that was just there and hit enter. And it opens on my other screen a little dialog box. And so what we can do is get a simple line drawing of this view, right? And so we could do a view of the C-plane, but I want a 3D view of this. I want the output layers, hidden lines as well. And it's going to make a new layer called Make 2D. So when I hit enter, or I say okay, what it did is it just generated these lines over here. And in 3D space, this looks kind of weird, but if I go back to my top view, this just produced this really simple little line drawing that both has hidden lines. And so you can see there's the Make 2D layer, the visible lines, and the hidden lines, but they're also gray. So let me change their color so you can see them. No better. Done. So now you can see those hidden lines behind as well. Right, so that's this really incredible thing to be able to have 3-dimensional geometry. Right, we had a view over here of this one object intersected with another object, and then we can see here's another useful tool that I use a lot, which is zoom selected. And we can see this is a flat drawing, but when we look at it from the right vantage point, say over here in the top view, as I go in bigger. So now this is like a nicely constructed orthogonal view with hidden lines behind there. Make sense? Cool, good. What I would do as well, right, just to like play a little bit with this, is that I might take this. It's not the best drawing. We can make a better drawing. I'm trying to keep an eye on the time too, and how much you guys can handle. but I could export selected and save this. I'll just work in downloads. I'm going to export this as an Illustrator file. Adobe Illustrator, let's call it workshop. I'm not even going to worry about the options, and I'll just save it. I can preserve the current view, RGB. I don't care about any of those things. I'll say fine. Let me open Illustrator then and open that file. Slowly opening.
Carl, while you're doing that, can I just ask one command?
Please.
You made the surface, after you did the Boolean difference, you made the surface so that it was just like all one surface instead of the mesh, I guess. Is that right? Just wondered what that command was. So that
I
you
think
got rid of
join.
all of the just join. You just selected it all. Okay, I wasn't sure. Okay, thanks.
And so, and that's and I can show you in a second too, because I made it look really easy. You're going to run into moments where it will join if those things are all in the right place, and it'll join it into one. If those are kind of like messed up a little bit, it may not join them correctly. But we can, I'll show you that. We can play with it. So what's nice in saving that Illustrator file directly out from Rhino is we have two layers. We have the hidden lines and we have our other outlines. And so what we could do then is to select, just really quickly in terms of a workflow, well, I don't want those to be pink. I want those lines to be black. And I want them, maybe the stroke should be a little bit thinner. And maybe even I'll come over here to stroke and change the dashed lines as well. Right, so maybe that's a little bit finer, and maybe I even want to mess with this a little bit more and get it to be where, let's see, which lines do I want? Maybe I want these to be a little thinner as well. So that I have a nice profile line around them. I can select all of them correctly. Trim this. Now you guys are starting to see. Well, anyway, let's see. Starting to be more specific about some of these lines and starting to develop a really kind of simple drawing with that, right? So in a matter of a really couple simple steps to be able to make 2D from an object, save it as an Illustrator file, and then bring that in and start playing with this. And then this will print really nice. We could add some tone. We could do something else. You've got a really simple workflow related to that. Make sense? So now maybe back to Susan's question is I'll start screwing some things up for us and show how it won't work. And this is going to be what'll happen when you guys start working, that not everything works all the time. So yeah, the question was like bringing those things back together to join them worked. But let's say if I go back a couple of steps and I explode this and I delete the top surface, and I join it all back together. That's one object. The other thing here, and again, I really love zoom selected. If you find yourself orbiting around using the right mouse button and it's all of a sudden off the screen. If you select an object and then use zoom selected, it resets the ability to orbit around that object. And now you can see as I spin around that, it just spins around this object, which is really nice. And so if you're working on a particular piece of geometry, it's always helpful to select it, go to zoom selected, and now you can kind of work around that piece. I'll do it again for this. And I'm going to intentionally screw it up and say, let's make a surface that's a plane, corner to corner, and it's going to snap to there, but I'm going to be sloppy and not snap to there, but think I'm snapping to there. And we can see the way that it kind of overhangs a little bit. I'm curious what will happen if I join it. It worked. And I think it worked because these two edges do line up. And so it's just that that one hangs over. So you might get a false sense that that's working, but we should also be able to trim that. So if I do Control T again, select the cutting object, enter, and then select the object to take off. Nope. So let me explode it and then do the same thing. Trim, select cutting objects. This face.
Chose to select the back and not the top, and then you went to try to put in your plane. How did you get those points to snap?
Say that again.
If you chose to delete the back opposed to the front or the top, I deleted the side and I tried to do what you just did, but because of, I don't know if it's ortho or plane or what, you can't, it doesn't automatically snap to the bottom and the top. It snaps, it runs along that plane. So how do you do that?
Perfect question, because that gives me a chance to talk about C-planes, which was the next thing that I wanted to talk about. But maybe just as a way to answer, well, to solve your problem, which really isn't your problem, Bettina, but if I join this together, one way that I can solve this, I think, is with a command that's called cap. And it says select surfaces to cap. And so I solved your problem, but I do want to use your question as a way to talk about construction planes. But sometimes if you have a planar face that's open on a solid, you can just simply cap it and that'll close it. But that's not your real question, right? So I'm going to explode this again. I'm going to delete that back face. I'm going to join this back together. And so Bettina's right. And thank you for asking that question, because if you were to make a surface that's a plane, that's corner to corner, watch what happens, right? The bottom corner we select, that's perfect and that works. But well, all of a sudden we have a problem because it wants to be in plan. But now as we select this point all the way up here, we don't actually get anything. And the reason for that is that it's defaulting to the plan view, right? As we rotate around, we can see that. And when we select this point up at the top, maybe even any of the points, what happens if we do that? Okay, so there's a new algorithm doing things. So it doesn't work for Bettina because this point to this point basically just makes a line, because it's a rectangle with no thickness. If we select the point that's up here, it's going to make a rectangle flat on the bottom. So in order to solve this problem, what we have to do is we have to change our construction plane. There's a bunch of ways to do this. So if we come to this tab on the top for C-planes, let's just mouse over them for a second and see what we get. So set C-plane origin. So if I move that, now we can see all I'm doing is moving the current C-plane. I'm moving its origin, the 0, 0, 0 point, around with that first tool. If I set the C-plane elevation, now you can see that it's lifting it kind of up or down, orthogonal to where that was. So now all of a sudden our C-plane is floating up here. And if we draw anything, it's gonna be floating up there, right? We can always return our C-plane back to where it was before, but we can also set C-plane to an object, to a surface, perpendicular to a curve. We can rotate it. We can use 3 points. And so Ian will be familiar with these things from Grasshopper in terms of how we were setting planes in Grasshopper and starting to define them. Here we can do it manually, set it by a Z-axis. We can set it to a view. We can set it to the top and to any of the sides. And so what I tend to do is, and I can never, and sometimes it doesn't really matter. So we can see top, it goes back to where it was. Bottom is basically just flipping it. So if we look at that for a second and remember your left L, that the green is positive Y, the red is positive X. If we go to bottom, it'll flip these, right? So now it's basically flipped that over. What we want, and I often find myself doing this, is bottom, front. So it's one of the side views. Because we're working orthogonally, now, as we rotate around in 3D space, we have the side view. And what I might do is just move the origin now to snap to there. Now our C-plane is vertical and its origin is there. It doesn't have to be there. So even if I move the origin somewhere else, remember, we don't have to draw on the C-plane itself, but we do have to draw, or sorry, we don't have to draw on the gridded area. But what we want to do is to get our elevation of our C-plane to be in line with that face. And so what we could then do is to draw now our surface plane corner to corner. On there. And now it snaps to there. Does it make sense? You guys can nod yes, but C-planes are a little weird until you get used to them. But just imagine that's that kind of, you're always drawing on a planar, you're always drawing on a plane. And what the C-plane allows you to do is to draw it 3-dimensionally in different places. And this will get even more difficult. And so, right, if we solve Tina's problem, we can then select our surface and we can trim that out. And now we have our object again. Let's do, I'm just going to make a new, we can keep drawing. I'm going to make a new file just so it doesn't get too confusing. Save. Let's make a silly little Monopoly house, because what that will do for us, right? If I were just to work in 3 dimensions, what I might do is draw a C-plane or change my C-plane to work in the right view or the front view. It doesn't actually, maybe let's say front, in the front view. So let's draw something here. The silliest of little things. Let's say 8 by 12 feet. And then this is like kind of how I would draft this thing. And then maybe I would fill it with a 0 radius to get these other 2. And then I've got that and I can join it together. Right? That's my kind of weird way of drafting something here. And I drew it this way. So then let's say I can snap to the midpoint, make something that's kind of roof shaped. I'll explode that, delete that one. I'll explode this, delete that one, and I'll join it all together. I did it really fast, I know, but just in terms of drafting something and how you would work with lines so that you could see, okay, I drew a kind of rectangle first with key dimensions and then drew a few other things. In 3 dimensions, what I would do is extrude this, even as a solid, extrude planar curve straight. And now we have that object. So what I would do in this case, and this is like a really simple way to think about the C-plane, is that what if I wanted to draw something on that roof, right? And there's 2 ways that we could start to think about something. It's how we could project something onto that surface. But let's say we have to be really specific and we have to draw a skylight that's 4 feet by 4 feet on that surface, right? The way that I would do that is I would set the C-plane to a surface and then hit enter a couple times. Now we can see that that C-plane is mapped directly to that surface. So when I draw something here and I want to draw something that's 4 feet by 4 feet, I'm drawing very specifically on that surface. And maybe I want to be very specific about exactly where it is on there, that it's maybe over 2 feet and down 3 feet. And now I can set this corner to there, and delete this line. And then I can, and here's the other thing with trimming. And one thing with views is that we saw it earlier. If I go to properties, there's a thing called ISO curves. And if I turn this up, it gives us all these extra lines on the surface. They're just for display. So we can turn off the ISO curves, but we can turn them on. And in this case, I guess it's only while it's selected. I was going to say it's useful to see when we're trimming something. So we can trim, and then trim that hole out. So now we have that 4 foot by 4 foot skylight because we drew it directly on that surface and all of our dimensions were right. The difference would be if we tried to draw this from the top view and we drew on the other side a 4 foot by 4 foot skylight. The way that I might do that is to just extrude, move it so it's inside, and extrude that surface straight up. Extrude planar curve. Extrude curve straight. There we go. And now maybe I'll get the intersection between these two to give me that curve. So curve from objects, intersection between the house and that object. And that gives us that line. I can trim that out. And so the difference between those two is that this is a 4 foot by 4 foot cut opening. This is a 4 foot by 4 foot cut opening in plan, but it's not 4 foot by 4 foot when it hits that surface, just given the projection and given those things. And so when you want to draw on a specific surface, right, even let's draw something on this face. I can set the C-plane to that face and then hit enter. Now the construction plane's there. And so if I wanted to draw something here, and here's another little trick, is that the snaps are pretty smart. So if I want to draw, say, a door, as I snap to the end point, it will also give me a kind of orthogonal perspective or perpendicular on there. And I can draw up and over and then down until it hits that snap. Oh, and then I was sloppy with that. So I can explode it. Delete that last line, right? If I wanted to trim that out. So these are the ways that you can start to draw. And again, construction planes are always flat. And so if you're working with flat surfaces with more complex geometry, it's easy enough just to select a surface and have the construction plane map directly to that. Make sense? Helpful? Is this coming back, Ashley? In a good way or a bad way?
I'm kind of nervous about all the commands.
The best way to do any of these things is first to get a little bit of exposure to it and then do a project with it. You'll be, the first time you use it, you'll be a little frustrated because you're like, oh, how does it work? Which command do I use? But after a while, it just becomes second nature. All right, you guys want to try and make something else? Still got some energy?
Can I ask a question?
Yeah, please.
So I noticed that the cap command works when you have a four-sided surface, but it doesn't like if you have a triangle. Is that correct? I mean, or at least it's not working for me.
Let's try it. So if you have a triangle like this and we extrude it.
Mm-hmm.
So let's extrude the planar curve straight. And so it's, what did I do? I do solid surface, extrude curve straight. Okay, so that's open on the top and the bottom. So if I select it and I say cap, mine worked.
Okay, it must be because I was making the house that you were making, but my roof is open and I was trying to close the triangular shape of the roof. I get something different from what you did and it didn't work in that scenario.
You want to share your screen?
Sure. Can you see it?
Oh yeah, yep. So I think it didn't work because I think your box, so click on your box and explode it. And then delete, I think there's a top surface.
Oh, okay.
And maybe here, yeah, oh, there you go. Yep.
Just
Now
delete
delete
that.
that. And, but you could try joining it and see if you can cap it. But it looks like maybe it looks like the left edge is maybe off just a little bit.
Okay. So it's not, okay. But it should work if I had it all drawn correctly then.
I think so. And I can try it really quickly too, as a way to do it. And so let's see. If you give me back the screen, let's see. I can. So what's nice about what you did too is you modeled it a very different way, right? I'm going to go super fast right now, but so front view, if I were to draw, I think kind of what you did was like, you took one of these, and this is also what I really like about Rhino is that you can work in a lot of different ways, right? So we have a box, we were going to extrude a box. Okay, maybe now from that same front view, I'll find the midpoint. And I'll draw a curve. That I can delete this. And I can extrude this curve. So extrude curve straight. We'll go in that direction. Right, that's kind of what you had. And then we explode this. Delete that. And let's see if what we were going to do a second ago works. If we join it together, and then we can try and cap it. Usually if those are planar open faces, it might work. So yep, that did work. I'm also really, really particular when it comes to these things. So one of the things that like bothers me is that in this, see this line across this surface, it totally doesn't matter if you're going to render. So if I go to like ray traced view, oh, it's only because we can see the lines. Let me rendered view. It's still there. Because those are the curves. So let me delete those curves. That's also a curve. Right, so it's a nice clean model in terms of the rendering. Like that's one face. But if I go back to the ghosted view, there's still that line across there. And so that would drive me, like, as I said, I'm very particular. So what I might do is explode this whole thing. And then there's a command of join these together and then merge the faces. Merge all faces. And now you can see it got rid of that line. And again, it doesn't matter. That line doesn't matter at all. But sometimes if you want to make really clean drawings, like sometimes that line might show up, other things might happen. But the way that Christy worked a second ago was like taking a box, extruding the box, drawing this and putting it together. The result is exactly the same at the end. And so this is the thing, as each of you thinks about how you work, how you build these things up, how you work with different models, it's totally open to that. Right? Because what we did is we worked with surfaces, turned them into solids, made it all closed, extracted things, exploded things, deleted things. So you can get to where you need to get to working in lots of different ways. So are we kind of good with that? You got a basic understanding of construction plane, working with some geometry. I want everyone to kind of understand you can work from, and here's another way that we could do. Contour is just one that I love. So we can take an object, we'll join it all together, and we can contour something, which doesn't make a lot of sense for contouring a house, but just to say that I really want to reinforce this thing that you can go from curve to surface to solid, from surface to solid to curve, from solid to curve, from curve to solid. It's basically just working back and forth between all of those things, right? And so if we contour this object, what we're going to do is we're going to go from, I don't know what one is. That's too many. Right, we're going to, the contour tool, lets us extract a whole bunch of lines or curves from a solid. Right? It makes more sense with topography, but there's a number of different functions that allow you to move back and forth between one type of geometry and another. Hey, Aaron Jones is here. Aaron came to say hi, right? So that gives us kind of working from curves to surfaces to solids, allows you guys to explode things, join things, and then we talked a little bit about construction planes, right? Make kind of basic conceptual sense at this point. Because what I'll do now is maybe show you some basic other types of surfaces, right? Which might be more complex surfaces, like how do we make a loft? How do we make something else like that? And so they're kind of fun. And so what we might do is just go through some of these surfaces as a way to do that. So loft and sweep and revolve and maybe patch would be a couple of the key surfaces that I would use. So loft is fun if we want to make a kind of, actually, let's make a kind of weird landscapey thing. So the easiest way to do that is to go into the front view and use a control point curve. And we can just make a couple of these and maybe make them, I'm being careful not to snap to it. And because we're doing this, we're drawing just one, they're all flat. So when we look from the top view, we can then move them to the side. The other one. And so when we look in the 3D view, we have these three curves. So the simplest thing to do is just loft them together. And say, okay. And now we end up with a kind of wobbly surface. Ian knows that I have like a lecture on lofts in a class that some of you will take in the near future. But this is a, really simple. What loft does is it takes just a couple of curves and then it draws a surface between them. And so we can also start to get a sense of that with the iso curves. That type of geometry that's there. And what's nice with this is that we can contour that. What I said earlier tonight in terms of a NURB surface, that the calculus of this allows us to find any point on the surface and it to be incredibly accurate. So if we go back to, say, our front view and we contour this, we get really nice geometry. Of those really nice curves that are here. And if we wanted to say make a simple plan drawing out of this, what we could do is project these again to the C plane like we did earlier. Delete them. So from the top view, we have just really simple contour lines that represent that surface. In 3D space, those contour lines are flat now, but it represents the topography of that surface. So we could export those lines and make a really simple drawing out of that. Did you guys make a loft? Are you with me? You want to try? You want me to slow down? You want me to go faster? What do you want? What does thumbs up mean? Faster and slower?
Did you go through it one more time?
Yeah. So I would, and we'll do it a couple of different ways too, because in this case, if I do it once more, and you can work in either the front view or the right view, but I would draw a control point curve. Just kind of, you get a sense for the control points and how to draw a curve like that too. But I would do it maybe kind of opposing curves. And then maybe even just another, like the third curve is maybe just a more simple arced curve through there. And so drawing all three of these in the front view means that in the top view, they're all on top of one another. So if we just select one and move it back, let's select another one and move it kind of halfway in between. Now in the 3D view, you can see those three curves. So again, I'll do zoom selected. So you have those. Everybody have those three curves now. So now if you select all three and just type loft, it's, I know that's, you can, I think the default is do not simplify. You can see there's a lot of different options in terms of like rebuilding it, refitting the curve, other types of things. But for what we're doing for now, I think you can say do not simplify and say okay. Then you'll end up with a surface. And basically what it's doing is it's taking, it's kind of dividing up this curve, it's dividing up that curve, and it's drawing the surface between them and basically kind of resolving that across its whole length. Did it work? How about a contour? You want to make contours through it? So I would go back to the front view or the side view. Select your surface. And you can see if you just move in one view, the active view is there. But if we go to the front view and then I just type contour, it asks for a base point. And you can just select somewhere toward the bottom, hold down shift, and then draw straight up and click straight up. And then you can play a little bit. We're probably working at different scales, but for me, 10 made sense. And it'll draw a bunch of contours through that. And you could even, instead of move them, copy them over to the side. And then in the top view, you could project to C plane. And delete the input objects, yes. It's not going to look any different in the top view, but on the perspective view, it just flattened all those down. You've got a really simple contour map. So the next thing you could do as we play with the surfaces a little bit is rather than draw those control point curves again in the front view as just curves, we could make them closed. And actually, let's do this. I'm going to make a new file. You don't have to do new. Large objects inches. This time, let's make the standard wobbly tower option. So rather than a topography where we're drawing an elevation and extruding it, we can draw 3 closed shapes in plan. And you can, in terms of closing the shape, you can either snap on the first point, or you can see there's an option up at the top. So you can just type C and enter, and it automatically closes it. So the same thing if we make 3 control point curves. Maybe make them different enough. We can then lift them up. And so in the same way that we did this a second ago, I'm going to come to the front view. I want maybe this one to be at the top. I want this one in the middle. And here's another, I'll show you guys how I work with iterations sometimes as well. Now we've got these 3 curves. We can select all 3 and we can loft. Now it's getting a little more specific. And so what you want to make, what it's showing you before it lofts them is the direction of the curves. And so we can play a little bit with this, but as long as your arrows are all moving in the same direction, it should basically work. Did it work for you? No? Who didn't it work for and why? Was Susan saying no to that?
Well, I'm not caught up with you. I was
Okay.
looking, it's okay.
No, but here I'll do it again because I want to show you guys a few different ways in terms of doing this. So I'll start over and I'll do it once more, because then what I want to do is if I go slow enough and each of you guys follow me, we'll make 3 or 4 iterations of these. And so let's, in the top view, make just a couple of closed control points. And if you type C and then enter, it'll automatically close it. I'm just going to try and make them different enough. So you guys have 3 closed control point curves. So then choose them in your top view. So I'm going to say, for me, this one was my bottom curve. Maybe this one is going to be my middle curve. This one will be my top curve. So if that's my top curve, I'm going to come down to the front view and move it up. And then I'll select the other one and I'll move that up. You can put it in the middle or anywhere kind of along there. And so then just come to the perspective view and take a look. But it kind of makes sense. Select all 3 and then type loft. I'm not sure mine. I might have to flip mine. But what you can do is you can move the point around. Seems like the arrow's all going in the same direction. I'll hit enter. Say okay. So my other one needed to flip. So I'll loft them again. If you click on the arrow, it'll change the direction. And if your surfaces may be a little too, or like mine, they can also be a little too extreme. But what this is allowing you to do is to kind of make a seam. And so that seam is kind of along one edge. Did it work for everybody? And so the way that I would work with a lot of these, this isn't parametric until we start to play with Grasshopper, but you can iterate with these things. So what I might do is to select my 3 curves and copy them, maybe to the right. And then we'll get a different result if we change. Here we can use the gumball to maybe move one of our surfaces down and over. We could loft these. You could play with your seams to make sure they're all kind of going the same way. The right way. That worked, right? So even with the same 3 shapes, their relationship to one another will result in a different overall form. So I could try it again. And so thinking about, say, a design studio, and we want to look at some different options. Here's a way that I would just kind of build these up using the control curves, maybe manipulating these. rotate them, we could do other things, and then we could loft this one too. So minor change within that, but results in kind of 3 different objects. We should be able to cap these as well. And now that became a solid. We could contour this as well, which is like a simple technique that adds a bunch of fake detail. Maybe 10 is too close now. And same, everything that we did earlier tonight in terms of intersecting something through that, make 2D, projecting surfaces or finding intersections between these things, we could start to work in different ways. So let's even, like if you made a couple of these, try doing this. Cap 2 of them. And because, again, it's not parametric and it's not grasshopper, I'm always constantly copying things, because if I'm going to change them, I kind of want to retain these guys, have them, I'll copy kind of up and to the right, keep moving up and to the right and keep moving over and keep doing all sorts of things. But what we could do is take, here's another thing. Let's move these together and make a few copies by using the gumball. I could rotate it slightly and they're still in the same plane. I could kind of smush them together and then select them and say solid union. And now just join them together. Right, but maybe using these 2 objects again, I'll make another version. And union those 2. And then maybe for a 3rd version, oh, I'm getting kind of turned around, is maybe I'll cut one out of the other. So solid difference, keep this one, cut that one out of that one. Now we get that. Was I too fast? Does it make sense? You want to do it again slower?
Makes sense to me. I seem to be missing my gumball. Do you know where that might be? It might help.
Look down here at the very bottom.
Okay.
There's an option down here and it looks like it's bold or
Oh,
not bold. So see what
gumball.
happens. See if you click that and make it bold. See if you get it at that point, if it shows up. Let's see if I did it.
It's bold now, yeah. That's the coordinates, right? The red and the green and
Yeah. And so that way, if you pull the red, it'll lock it in that direction. Or if you pull it green, it'll lock it in that direction. Or if you use the blue, it'll orbit around that center point.
okay. I spooled now, but
So, but if you have,
okay, I
you have
got
to
it.
click on an object to get
Yep.
it. Yep.
I got it. Thank you.
And so the other thing that I'm trying to start to show with this is the way that you can kind of quickly make some iterations, right? So we used the same 3 shapes, and then we kind of copied them and we made a different set of relationships between the 3 shapes, which gave us different lofts. And then we can even just start copying these, intersecting them or unioning them, differencing them, doing any number of things as a way to produce. So even if we went, that's not a solid. If I grab these 2, copied them. So another way, we've done difference, we've done union. We can also find the intersection between these 2 objects. And so same thing under solid and intersection. Now this is the intersection between those 2 objects. Right, so there's with a couple of simple moves, we now have some pretty complicated geometry. So that's loft, and that's just, we did it with 3 shapes, you can do it with 2 shapes, will give you a kind of simple thing. 5 shapes, 100 shapes, you can use any number of things, open and closed, and you can make all sorts of refinements with those things. The one thing, 3 shapes, not to get too much into geometry, with 3 shapes, you'll get doubly curved surfaces. But if you loft between 2, let's see if this is true or if this works. We draw 2 shapes in plan. This time I'll do them as open, but it doesn't matter too much if they're open or closed. And this is also related to the kind of way I talked about a NURB surface and being able to calculate these. If I loft between 2 objects, we now have this geometry. And it also gives you a little bit of a sense that there's always a straight line drawn between these 2 curves, kind of divides them up. But what's also really nice about this is the ability to unroll these types of surfaces, which is another command. And if we're going to deal with fabrication or any of those things, unrolling is an important thing. And this then is that surface flattened. So between here and here. This is standing up and this is unrolled. But again, not to get too far into these things, it's a specific type of geometry that we can unroll within Rhino. Should we look at another type of surface? We've got sweeps, we've got, and maybe patch are a couple of things that we can look at. So, and revolve. So let's make, you guys got a little bit more left in you? Ashley looks like a little bit. And Renee's like explicitly a little bit. So let's just look at a couple of other surfaces then as we build these things up. So I'm going to make a new large objects inches. And so like the wine glass is a kind of pretty common type of geometry that we can make, and it's called a revolve. And it's like if you were to put something on a lathe. And so what we would do is draw a shape. And I'm going to do this in the front view. Doesn't have to be a wine glass, but imagine a kind of shape and imagine revolving that. I think we have to draw an axis. I don't use this too much, but let's see. So surface, revolve, select the curve to revolve, start of axis revolution, end of axis revolution, start angle, 0, and 360 degrees. But that's any type of surface that might be revolved. So if you have to make a cone, that would be that type of geometry. Are you guys able to make it?
Can you do that one more time?
Yeah. And I'll do it maybe more. And so maybe what's good is I'll start with the axis this time. And so in the front view, I'm going to type 0, which will default to the origin, and hit enter. And then I'm just going to draw a vertical line. And then I'll even do it with a polyline this time. A kind of jagged line. So those things are just 2 shapes there. And then we'll go to surface, revolve. So it says select the curve to revolve. We'll select that first and then hit enter. And then you can just draw over that axis that you want to revolve around. The start angle is the default is 0, so we can just press enter. If we want to go 360 degrees all the way around, that's the default, and we can hit enter again. And then you should get a shape that's been spun around there. That worked? Let's do a different type of surface then. So what else do we have? So, and sweep. These get into some interesting kind of things. And so let's see, sweep 1 rail. Let's do sweep 1 rail and see what it asks for. So it asks for a rail. So let's maybe in plan, draw a kind of curved shape. And then sweep 1 rail, select the rail. What else does it want? And it wants a cross section. So here's a good way to reinforce a C-plane or construction plane. So let's maybe at a different scale. I'm going to draw a big, just kind of meandering curve in plan. And what it wants is let's extrude something along that curve, like let's say a handrail or something that's just a kind of round shape. But in order to draw that round shape, we have to do it perpendicular to that path. And so let's go to C planes. There is an option for that, which is set C plane perpendicular to curve. I think if we select the curve, now we can draw, we can put the C plane anywhere along that curve, and I'll just select the end. And now if we go to the end, we can draw something there. And I can do this again in a second, slower if people want me to, but then we can sweep 1 rail. It asks for the rail, then it asks for the cross section, and then we press enter. And then there's a whole bunch of options, which I'm not even going to worry about, but then we get now something that follows that shape. Did it work for everybody? Do it again slower. Yeah. So I'm going to go back to the top view, or top view, the top C-plane for us to draw that kind of meandering, curving path. And then what we want to do is to draw something on the path. And so we're going to use that, the fourth button over, which is set C-plane perpendicular. And select the curve and then just choose the endpoint on there, which will put the construction plane at the end of our path. This time I'll just make a rectangle. And then we'll go to surface, sweep one rail, select the rail, select the cross section. It asks for the seam point. I'm not going to care about it. I'm just going to press enter. I'm not going to care about any of these other options within here. I'll just say okay. We can get really complicated in terms of like doing different things along the path, doing all sorts of things, but basically all it's doing is taking that shape that you have at the end and extruding it along that path. That path can be three-dimensional too. So if I wanted to come here, we can see these control points. So if I click a control point, I think I can lift that up now. So all of a sudden this starts to become three-dimensional. I can push this one down, push this one down. All right, so now all of a sudden that curve is more complex than it was a second ago, but we should be able to sweep one rail. And now we have even more. Not that the goal is to make complex geometry, but when you need to make something that's specific, you've got some tools to do that. Did it work? Renee, did it work? You want me to do it again? No. All right, how about one more surface for tonight and then we can call it quits. So the last type of surface, and you can see there's other options under there. There's another type of sweep with two rails and some corner points, some edge curves. We can extrude, which we did very early on. The last one that I'll do is called patch. And so the patch surface is pretty sophisticated. And I sometimes use this to do topography. And so what patch will do is if we draw, I'll draw alongside the construction plane, make a kind of perimeter for something. So we could make a flat surface this using a planar curve, but what we can do is maybe either use curves or points. Let me use a couple points. And so if I set a couple of points inside this bean shape, they're flat right now. If I use the gumball to go maybe move some points up, move some points down to varying heights, we can see where those points are. What a patch surface will do is it will work very hard to give you what you're asking for. So select curves or points or anything. So I'm going to select my points and that curve and press enter. And now it asks for a couple of things, which is the number of kind of divisions across it and how stiff it is. And so this is something that I often do iteratively, but what it's going to try and do is to draw a surface so that it hits all of those points and all of those curves. And if it's too stiff, it maybe can't do that. And if it's too the opposite of stiff, it maybe can't do that either. And so what I'll do is I'll just, again, keep kind of iterating. I'll delete this surface, but maybe select everything again and make another patch surface. And maybe change now, if I make it more stiff, change it to 1. It seems to still work, okay? There are some times where it can get really crazy. Maybe when it's not stiff at all, it'll start to like make really big peaks and valleys between them. Right, so that's weird and stupid, but at least you can see it made a different, slightly different outcome. So this is one way that I might make topography when I have a set of key points and I have a perimeter and I want to just kind of map. I want the surface to go through these kind of minimum points or these other types of points. It also works with contour lines. So if I just took the perimeter, maybe drew another I actually don't even have to be closed, right? So I can move this up, move this one up. Then if I patch these, it should try and go through. So the same thing, what I might do is contour that to better understand that topography. Did everyone get a patch surface to work? It's basically just like a big piece of rubber stretched between whatever geometry you give it, which can be good and can be bad. It can be, it's as precise as the inputs that you give it. And so I've often done things like iteratively worked, like, okay, I might take it and contour something and then use those contours and maybe adjust the contours and then repatch the surface, or, you know, kind of just keep working on something as a way to get something to be where I needed it to be. But in the best case, right, if you're working on studio work, I would just like use underlying curves or geometry and make surfaces from that. And then maybe I'll copy that geometry or copy that surface, make a modification, copy that, and then make another surface out of it, and then maybe cut it and copy it and do something else. And so what I have, I didn't bring any of my files, maybe tomorrow night I'll bring some other examples, but some of my design files, there might just be 30 or 40 different objects kind of sitting in that space, because I might want to go back to something and I could extract some of those curves and I could do something. And so it's almost like a branching. I think I tend to work left to right in terms of like one type of difference. And then if I make minor changes, maybe I start working in plan, like one way might be in the X direction, the other way might be in the Y direction. We haven't done much either with layers tonight, but our curves for our contours might sit on one layer, our surfaces might sit on another layer. We could start to name things. You've got kind of infinite control as it relates to the layers and your file management as well. So I think we're at a good point in terms of working through some of this. What I'd like to do is maybe tomorrow night, if you want to come back, is to take some of these things and and maybe build a kind of small object and start to look at producing some drawings from it, producing a rendering from it, taking those things into Photoshop, taking the drawing into Illustrator, and maybe have a kind of plan cut, have a section cut, and look at that as a workflow, if that makes sense. Anything not clear from tonight? Too much for tonight?
Are you going to email us the link to the video when you process that?
Yeah, but it won't be tonight. Do you want it do you want it tonight? You don't want it tonight anyway.
Well, I'm not in Michigan, so I'm a lot earlier. It's a lot earlier. It's okay.
It might be, I have to figure out where we'll post it and a couple of other things too. I can stop sharing my screen too. All right, any requests for tomorrow night?
I just have a rendering question. I know that usually Rhino is in conjunction with V-Ray. Is that something that Rhino already has embedded in it, or is that like a separate plugin? I know before it used to be separate.
It's still a separate thing, and we don't have it at LTU, but the rendering within Rhino has gotten a lot better.
Okay.
And so I don't have a renderer, but I use it, and tomorrow night we can just do like some simple shadows on something, and they do have an embedded kind of real-time ray tracing within Rhino.
Okay, awesome.
So it's gotten better, maybe to the extent that, well, okay. Do you have Rhino 7, Aaron? Did you get it? Only chat tonight now. Oh, do you have a sleeping baby next to you? Is that what's happening?
No, I can talk. I just haven't said anything in a couple hours out loud here.
So that sounds good, and all of you should have access to Rhino 7 if you work with the help desk. And so I think we probably don't need V-Ray, but V-Ray is also nice in terms of the materials that it has and other things too.
Hey everybody, my name's Aaron. I recognize some new faces. And Ashley, your question about V-Ray too, we looked into it specifically at the college, and some of the cost benefit for us to purchase licenses for everybody was pretty heavy. But almost in every case, like if you start to become interested in something specifically, you can get a trial version for a month or something like that. And so like if there are office kind of like if your boss or like a future job is like, hey, we use V-Ray specifically, there's lots of workarounds or things like that. And in hyper-specific cases, it's actually not the most expensive thing to buy as an individual student license either. I think it might be right around $100 or something. For our school, they just didn't give us much of a bundle price break. So I think it was almost more than what we paid for Rhino itself to have the plugin.
Times all the students that we wanted to have it too. So you can imagine that got pretty expensive.
And pretty quick, students start to feel comfortable in a variety of different like rendering things too. Inkscape, V-Ray engines, game engines, any number of other things. Yeah. And so there's a lot of other things out there. But Carl's point about the Rhino 7, you have the option to use the Rhino 6 rendering engine or their new rendering engine. They call it like Rhino Legacy or something like that is the old one. And they're pretty good.
Good.
Okay, thank you so much.
I just have a specific modeling question, I guess, based on just, I used to use 3ds Max a lot. And so I guess my question is, because this is a surface-based modeler, I would love to see like an actual model that you did, like you said, a house, where are you doing the actual thickness of the walls and modeling the frames of the windows, or are you doing more of just like a paper thin version of that.
I'm doing, and maybe that's a good point. Maybe I'll bring that tomorrow night and show some examples of that. What I would do, and maybe just if you want, just for, well, I'm not going to model it, but what I would do is basically draw the plan, or what I've been doing this summer is like drawing the plan, and that those walls have thickness, and then I might extrude those walls, and then I'll start to kind of put floors in, and I might cut. I'll use the C-plane like I was doing tonight to draw the windows in elevation on the walls. And then I'll kind of extrude those through the thickness and I'll trim those out. And so that's the way that I'll basically build up the kind of thickness of those things with those kind of objects or with those pieces. So it's, in the end, all those things are paper thin, but I think what you're talking about too, it also depends on maybe where you are in the process. So if you were to do a massing model, that might just be, the walls would be paper thin and the whole thing would be a solid volume. As you get into more kind of detailed things, the walls would have thickness. As you get more detailed from that, I might have the wall, but then I might have the cladding sitting on top of the wall, right? And so, and the way that I would tend to work is, as the project advances, the Rhino file probably gets more and more embedded into it. And so I might have the original massing, although it never really works like this. You could imagine a way that you could have a layer that's your original massing file, then another layer that starts to have the wall thicknesses, then other layers that start to be objects that are kind of hung on that. So it's almost, it's not a BIM model, but you could start to imagine building a level of detail into the Rhino file.
Okay, yeah, that makes sense. I mean, I use SketchUp a lot too, so it's very similar. And I'm trying to relate SketchUp to this, where like, for instance, if I want to draw like a facial line and an eave, how I would offset those lines in SketchUp is very simpler than I just push pull. But how do I do that in Rhino? Like those kinds of connections, right?
Yep.
So yeah, maybe tomorrow if you could show maybe some of those simple kind of ideas, that might help.
Yeah, and I can bring some like pretty intense Rhino models for like competition projects or other things, and how we've organized those and set them up too.
Yeah, that would be awesome. Thank you.
Cool. Does it work for you guys? So we'll have the recording at some point. I'll let you know where that is. I may end up just posting it to my YouTube channel. And then you guys also have that outline from tonight too. So if you have those kind of notes, I think I mostly followed it and you can kind of get a sense for those, but also at any point, if you run into a problem, feel free to reach out. Okay. I'm as exhausted as you guys are. So that's good for tonight. Let's take a break, and then I'll share some examples tomorrow night, and then we'll do a kind of workflow of like just a really simple space, cut it, we'll make some drawings, we'll make some representations, we'll bring them into some other software so you can see that workflow. All right. All right. See you guys tomorrow night.
Thank you.
All right. Good night.
Thank you.